Welcome to this talk about the annotation tool ELAN, in which we will discuss recent developments and reflect on future directions. Although ELAN has become a relevant tool in many language documentation projects, I'll start with a quick introduction of ELAN. It is a standalone desktop application for the manual annotation of audio and/or video recordings. It supports multi-layered or multi-tiered time-linked annotation of recordings involving multiple speakers or participants. Annotations are grouped in tiers, a kind of layers. Tiers can be interrelated and the user can create any number of tiers necessary to capture all the phenomena the user is interested in. ELAN stores the data produced in an XML file. The format is called EEF and the file extension .eef. Most part of ELAN is written in the Java programming language and is platform independent, but important parts are platform specific. We create distributions of ELAN for Windows, macOS and Linux. It is free software and open source. The sources are available for download. The current version is 6.4. Usually we release 2 or 3 updates per year. The URL of the website is shown on the slide. Since this is a kind of an update talk, I'll start with discussing a few newly added functions. Here's a short list of new features, some of which will be discussed in more detail in following slides. We've added a first version of a Spectrogram Viewer. We've added support for audio visualization directly from video files. A new annotation density plot is now available as an export option. Annotations can now be created by entering precise time values for the start and end time. The structured multiple file search now allows to search for annotations on a specific tier where there is no annotation on another tier. A new export as time-aligned interlinear text has been added. Remote media files are supported, and an interlinearization mode has been added. This last function is not very new, but hasn't been presented much before. I start with the Spectrogram Viewer, one of the more frequently requested improvements of ELAN. The first implementation of a Spectrogram Viewer has been added in ELAN 6.3 and is intended as a visible aid in the segmentation and annotation process. As shown in the screen capture, it is a separate viewer positioned just above the signal viewer. Currently only available in the main annotation mode, the viewer can be hidden or switched off like most other viewers if it is of no use to the user given the task at hand. The Spectrogram Viewer displays a spectrum of frequencies found in an audio track. The horizontal axis represents time, like in the signal and timeline viewers. The vertical axis represents frequency, and the color intensity represents the amplitude of a frequency at a given time. The viewer has the usual options to zoom in and out, and it allows to specify a channel for which the spectrum is shown, left, right, or both. A configuration window allows for changing the range of displayed frequencies and for setting the color and contrast of the image. A spectrogram is created by repeatedly applying a transformation to a small set of samples, a so-called window which slides over the audio samples. The size of this window can be set as well. A smaller window, which means with a shorter duration, gives better time resolution. A bigger window leads to better frequency resolution. This is still merely data visualization, and the option to open the file or a selection thereof in Praat will remain. There is no intention to reproduce the functionalities that Praat offers. Interaction and data interchange with Praat remains important. Possible improvements that we consider are combining the spectrogram and signal viewer in a single viewer. This saves resources. And an option to show the selection in a separate window with more detail. Until very recently, a WAV file was required as one of the linked files in order to get a visualization of the waveform in the signal viewer, and now also of a spectrogram in the Spectrogram Viewer. In case of video recordings, a WAV file has or had to be extracted from the video first. This is still the preferred and recommended approach. But since there are situations where extractions of a WAV file is impractical or impossible because of limited available time or disk space, we have worked on extraction of audio samples directly from a video file, for the purpose of visualization only. The implementation is based on so-called native frameworks, so there are in fact multiple implementations. Although this is in principle a nice addition to the program, at least that's what we think, there are several drawbacks. The processing requires a considerable amount of resources in terms of CPU time and internal memory, and some frameworks or the interaction therewith sometimes seem to lead to crashes of the application. This is unfortunate, so use with care. The next thing I would like to mention is the export of an annotation density plot. As the screen capture illustrates, the plot is created in a separate window with a preview and configuration controls. The density plot shows the distribution of annotations over the timeline. It gives a quick overview of position, frequency and co-occurrences of annotated events. There are several configuration options. Tiers can be in or excluded, and their order can be set. The size of the image and parts thereof can be set, and the entire media duration can be shown, or just a selected time interval. In case some of the tiers are linked to a controlled vocabulary, the color coding of the CV entries is shown too, like in the image of the previous slide. The result can be saved as a PNG image. As a possible extension of the current functionality, this could be turned into a live viewer too. This way of visualization is quite common in tools for behavioral coding, but is probably useful for most types of annotation. The next thing I like to discuss is a new export option, the export as time-aligned interlinear text. In this export, the formatting of the output, the positioning of elements, is based on the time alignment of annotations and on a character-to-time ratio. The configuration window allows to select the tiers to export and to set the style for each tier. Important for the result is the time unit, the number of milliseconds a character or character position in the output represents. Contrary to the other interlinear text export options, where it is important that the text is exported without omitting parts of it and where the interlinear positioning is determined by the length of words and sentences, in this export the emphasis is on visually maintaining the time relations between annotations. As a consequence, parts of the text may be cut off if there is a disparity between the duration of an annotation and the length of the text. The output is stored in HTML because of the styling that can be applied. Export to plain text without the styling is planned for the future. I'll now move to the interlinearization mode. This is actually not a very recent addition, but it hasn't been presented much before, so we like to mention it briefly here. It is a text-oriented mode with an interlinear glossed text style of user interface. Originally, this was thought of as a kind of front-end or client in a configuration with the lexicon tool Lexis and an extensible set of NLP, natural language processing, software components, so-called analyzers, together named Lexan, to provide, for instance, computer-assisted parsing and glossing. After the end of the development of Lexis, we had to reorganize the plans and started to develop a small and basic lexicon component, which now is a part of ELAN as another extension. The analyzers still needed considerable amount of work once the lexicon connection became available. Since ELAN is flexible in its tier setup, it doesn't have fixed predefined tier types for words or morphemes, etc. Some configuration has to be performed before analyzers can produce suggestions for the user to disambiguate. The lexicon component, which has been developed for this mode, provides a basic table view and a separate editor for the lexical entries. Multiple lexicons can be created and linked to tier types. The lexicon data model is quite similar to LIFT, lexicon interchange format. It contains a number of predefined fields and allows for custom fields to be added. Interchange of transcription data with flags remains important, and the import and export function for flags via flags text are updated every now and then. But the data exchange will probably never become trivial. Maintaining a tool for so many years requires regular updating for new versions of supported operating systems, for software frameworks, Java mainly in our case, for new hardware, for available repository frameworks, and for evolving user requirements. Over the years, the code base grew considerably in size and complexity. To keep the code maintainable, documentation and restructuring efforts are almost always required and ongoing. A more thorough restructuring and modularization effort is now starting. Once this is finished, there should be a cleaner and easier to maintain codebase. This should, for example, enable the integration of simple ELAN as another working mode in ELAN, and should make it easier for third parties to extend the software in various ways and contribute their improvements to the main source base. Many years ago, we started working on making it possible to combine ELAN with tools or services for automatic or semi-automatic segmentation or annotation, via another of the mini APIs that we have. WebMouse, the MPI Fraunhofer audio-video recognizers, WebLicht are examples of options that are currently available, and we expect that this will be an area where improvements and extensions will be necessary. Reduction of the amount of time required to annotate recordings is something that probably remains important in the years to come. If the International Decade of Indigenous Languages still requires manual annotation of multimedia recordings, this effort should ensure that ELAN can still be available to the language documentation community. Thank you for your attention.